Well, there we are. Hello, everyone, and welcome to another episode of Feed My Sheep, Earthquake Reports, and more. I'm Terry Rempel, and it's the 16th of January. We did a couple of programs earlier showing our carte blanche, the best cart in the world as far as we can find for packing gear and allowing you to move more freely, move further and faster with heavier loads. Much better for older people. So we are, or people with anyone. It just makes it easier to pack loads on wheels than packing them on your back. Anyway, we've got a big program tonight. We're starting all the way down southwest of Holtville, south of Salton Sea. There's been a lot of activity along the San Andreas. There's been a lot of activity off the Mendocino as well. That's continued. But we're going to start with this swarm. So we've got a small swarm down here southwest of Holtville. This is what I took this yesterday. So we can see it down there. And that's Salton Sea up there. Get a little closer. The largest reported was this at a 4.09. That's a lot of earthquakes down there. Now, what's causing it down there? There's a combination of both faults and magma. Looking from El Centro, we see the largest earthquake here. El Centro is the closest seismic site. There's the 4.09. And this is on a fairly quiet El Centro seismogram because it's at night. Quieter at night. And later on the 16th from El Centro, this is back to its normal busy state with a little extra thrown in. We've got an earthquake in here, and it's really hard on this one from this site to pick the earthquakes out from the geothermal magma-related activity down there. There's a lot of magma near surface. That's why all the geothermal is down there. And this is a previous seismogram from El Centro. This is without any extra earthquakes on it. It's just that busy down there. And this is why we find long period pulse magma signals to the north at the Wister Waterfall Preserve site, because magma is moving through that fault system down there. So these are long period pulsed magma signals. We see the same thing at Bombay Beach. We've seen this for years. We also track these signals north to the Mirage site. Now in the San Jacinto Mountains at Cabazon, south of Beaumont, northern San Jacinto Mountains. We can see them in Beaumont. They're a little finer, a little harder to pick out, but they're still there. They're quite prominent in San Bernardino. And they track west from there to the Walnut La Puente site. Very active site, and has been for years. North of San Bernardino at the Lugo site. So what's going on with all of this long period pulse magma signals? We have magma infiltration of the southern San Andreas Fault. The Imperial Fault is the southern extension of the San Andreas Fault, and it also has magma infiltration. We also have infiltration of ancillary faults that extend to the La Puente area and into the Mojave Desert. It is common in geology to find plutons that follow faults. What are plutons? Plutons are magma incursions that have cooled down. Sometimes they remain deep, sometimes they reach the surface. Rivers often run in faults. The Columbia River runs in a major transverse fault that produced massive deposits of basalt along the river in eastern Washington and Oregon. And so it's an excellent example of magma production coming up through a fault. The Columbia River has many seismic sites showing long period pulse magma signals. So it has them just like Bombay Beach and some of the other long period sites that we've looked at. The Fraser River in BC also shows pulse magma signals from the Hope site. And the Fraser River has associated volcanic features upstream of Hope. Magma infiltration of faults in North America is both a historical fact and a current reality. I've displayed seismograms in NorCal for years. Now we're going to look at NorCal. Mount Lassen and Mount Shasta have shown themselves to be increasingly active. We've even had a pair of magnitude 4.5 earthquakes at Lake Almanor south of Mount Lassen a couple of years ago. This included reactivation of the lava beds areas in Medicine Lake Volcanic Center south to Susanville. This also goes across to the Black Rock Desert and involves portions of Nevada. I used to show the accelerated activity all around Lake Tahoe and the growing activity through the Sierra Nevadas. I haven't done that for a while. I am confident in the data that showed that the Sierra Nevadas were reactivating along with the Cascades range. I could show both the shoreline tremors of NorCal increasing and the resultant increased activity in the Sierra Nevadas and east of them in Nevada. Nothing has changed except that all the agencies have cut off public access to NorCal seismograms. I don't have access to those right now. They've been shut off for over a month. That includes, more recently, the USGS. So here are some of the images I archived of, this is Clear Lake Volcano on the 14th of August, 2025. So lots of activity there. This is typical activity northeast of Mount Lassen. Still over the magma chamber with that proximity. North Mount Lassen. And this is North Mount Shasta, typical activity, long period pulsed magma signals. And this is Medicine Lake. Medicine Lake was getting very active. A little bit of south of Mammoth in the Sierra Nevadas. This is the 23rd of October. So I continue to archive data as I go. I don't necessarily do a program, but I archive a lot of data. Mammoth itself looks quite different. So you look at this one, south of Mammoth. And this is Mammoth itself. So you can tell that the activity in the Sierra Nevadas that I just showed that south of Mammoth is independent of Mammoth itself. Part of why I keep saying Mammoth or the Sierra Nevadas are reactivating is both combination of the earthquakes that are occurring there that are reported and the seismic activity that we're seeing, or we have been seeing for years. Just because they turned off the seismogram doesn't mean the activity's gone away. This is South Shasta on the 13th of October in 2025. That's some major uplift fracturing. That's a lot of infill tremors. So the point is that all of NorCal continues to show responses to accelerating subduction creep, and this pattern has displayed itself for over 5 years. Turning off the seismograms doesn't change that. The Sierra Nevadas continues to reactivate due to subduction creep, and this points to the Great Cascadia megaquake being longer and thus larger this time around. If you make a subduction quake longer, it gets larger. The activity tells us this will involve all of California. So that's an increase of hundreds of miles in the south. But the north of where the normal Cascadia stops, which is kind of midpoint Vancouver Island, also shows dramatic increases in activity. The Alaska Panhandle, southeast Alaska, including Mount Spur, the closest volcano to Anchorage, there are 3 reactivating volcanoes along eastern Alaska, 2 of which we called as reactivating over 6 months ahead of any agency confirmation. Those 2 were Mount Spur and Mount Edgecumbe. The 3rd reacting volcano is Warrenkovsky Island, the site southwest of the town of Wrangell. That's on the very south end of the Panhandle, Alaska Panhandle. Excuse me. And this was from the 16th of January, and this is Warrenkovsky Island blowing off steam, according to the seismogram. So that's a lot of activity at Warrenkovsky Island. It's a volcanic island about 4.5 by 6.5 miles, something like that, rising straight out of the ocean. And this is later in the day at Warrenkovsky. Now you'll notice this earthquake. We're going to get into this earthquake right here. And it shows on 3 systems. We just saw it on AVO. We see it on PNSN seismograms and USGS heliplots. This is the closest heliplot site, Neilton Lookout, and it's on the Olympic Peninsula. It shows it at the earliest, right at the 3:30 mark. So there it is there. 3:31, to be more precise. And this is the Blue Mountains array. We're moving further away, and it shows it a couple of minutes later. It's about 3:33 here. I can double up this, and you can have a little closer look. So there's a minute past the 3:30 mark right there. So this is an unusual earthquake. I didn't find it reported by any agency, and it's large. It's large to show this large from Hawaii, and this is a very unusual signature. And it shows this large down in Palmer Station, Antarctica, as compared to Fairbanks, Alaska. So if they didn't report this, and it's a magnitude 6 plus earthquake, why? Why not? Looking from Sydney on South Vancouver Island in a real-time seismogram, we're looking at the first section of the earthquake, right here. And you can see it's very, very high frequency leading into this. And this seismogram shape is unusual, does not match a natural earthquake. Oops, let's get rid of that. So that's a very high frequency signal, and the location looks offshore in the area of North Washington and southern Vancouver Island. Now, many may not realize, but you can go on shipping, and you can see that there's a great reduction in freighters waiting to access the Port of Vancouver and ports on Vancouver Island. So the number of ships that are in BC has dropped dramatically. There's some news around, some scuttlebutt, that there's a bit of a blockade going on. Protection of the U.S. is part of that. And so we wonder what happened here to produce such a high-frequency signal offshore that would be a magnitude 6 plus and reach all the way to from Antarctica, with a signal, good signal, all the way to Antarctica and all the way to Fairbanks and over to Hawaii, and then not be reported. So this was a massive episode. And I can't say what it was, but you'll have to read between the lines. A very high frequency signal. Anyway, looking at the entire signal from Oil City on the Olympic Peninsula, we see the conversion of very high frequency to very low frequency that occurs when high frequency vibrations move through the crust of the Earth. They convert to low frequency or very low frequency. So that's what we're seeing here. See the initial quake set and then the conversion to low frequency. Not natural. Now, if we look at Turkey earthquakes, the 2 that we had, looking from Portugal, we see the same phenomenon, and I described it in that program, high frequency converting to low frequency. So I'm using back data from the Geophone Potsdam site. And it shows the same thing here. Looking from, in this case, Germany. And this is looking from Kenya. Very dramatic change. You can see with distance it makes it very obvious. So back to the Cascades. This shows Crater Lake Wizard Island uplift fracturing. Right up there, a little bit there. Certainly tremors of infill associated with that. North to the Cinnamon Butte, and we see the activity down here with uplift fracturing. And major infill at southern Newberry craters. The top of the seismogram doesn't show, but it's got about an hour of this very, very dark, completely infilled portion. So this was the looking at through the PNS seismograms at the same site. It shows the activity here as wavy lines. USGS does show these sites a little better in this case. Central Cascades at Finn Rock. This is southeast of, or southwest of Sisters. So there's quite a bit of magma movement there, lots of tremors. This is Moon Mountain near Bachelor. It's got some tremors as well. And this is CC Butte north of Mount Jefferson. The Mount Jefferson site BPO is not functioning currently. I can't get any data from there, but it has been busy of late. So this is CC Butte. You can see all the fine tremors through there. And this is the Johnson. Mount Hood is not that busy right now, and neither is Trade Dollar Lake or TDH. Tom, Dick, and Harry. Sorry, this is Johnson Ridge Observatory at Mount St. Helens. So this is over the magma chamber, but up to the north. Lots of activity there. Of course, Mount St. Helens is a rebuilding volcano, so it has lots of activity like that. That is typical. And at Mount Hood, these are typical tremors as well. Moving north between Mount Rainier and Mount St. Helens, this is Watch Mountain, and this is tremors early in the day. Tremors later in the day. You can see I haven't changed the size of these at all. They've just gotten larger. The intensity has increased. This is typical Mount Rainier from Camp Muir. We've got some small earthquakes there. The south flank of Mount Rainier. This is northwest Mount Rainier. So it's active all around Mount Rainier as normal. It's been a reactivating volcano for many years. This is the southwest base of Mount Rainier at Gobbler's Knob, and you can see the activity is pronounced more around the base, but there's been quite a bit of flank fracturing in the last few months as well. This is the Greenwater Fire Station well north of Mount Rainier. And this is Rattlesnake Lake, also north of Mount Rainier, north of the Greenwood Fire Station. Rattlesnake Lake has been a very active, magma-active site for quite a few years. I just saved this one of the earthquake offshore of southern Vancouver Island. This is looking from Adele, Oregon. That's the furthest site for PNSN. Pretty much the furthest site away from the earthquake location. This is Glacier Peak. We have some tremors, activity there. It is an active volcano. Mount Baker has fairly constant and light tremors. Warrenkovsky Island again today. So we've got some earthquakes right at Warrenkovsky. Lots of small tremors. Some probable steam releases. Compared to Mount Edgecombe to the north, this is a Mount Edgecombe earthquake, or something nearby, closer to Mount Edgecombe than Wrangell, certainly, and related tremors. And Mount Edgecombe is proven to be infilling with uplift detected by satellite and confirmed by USGS. They had a researcher go through all the data there. It's got quite a bit of uplift. So looking to the north, the panhandle of Alaska up in the north. This is the Yukon here. This is the northern border between the Yukon and Alaska. So this is where this was, and we had a whole bunch of earthquake activity up there. What I called shear fault earthquakes, and this is what it looked like. It was 3 weeks or 4 weeks ago, and it developed to this. And this wasn't all of them. Not all of them by any means. There's a huge number of earthquakes. And locally, this is local activity to where we live on near southern Vancouver Island. This is offshore of Galiano. And we've had significant shaking. We had an episode where our 6-foot fence was rattling all up and down the length of it. We were outside at the time, so we had a good shaker through here as well. So the tremors are increasing. The volcanic activity is increasing. But the big thing is it's increasing to the north and to the south, with activity in California, activity in the panhandle of Alaska, and in the Yukon inland, where there has been very large historic shear faulting. That's an area of shear faulting, and that's why this is as wide as it is here, is because when you have a shear faulting, and it's if the shear is angular rather than vertical, that's what a shear is. It's going to produce earthquakes over a wider, broader area. So the fault would be this way, and the shearing would extend it north or perpendicular to the fault. So that's a lot of information to cover. So we've got things going on offshore that we're not being told about, with large activity. We've got magma incursion and faults and lots of activity. We've got reactivation of the volcanoes, and things are continuing to move forward in a rapid creep fashion, accelerating towards an eventual release of the great Cascadia earthquake, except this time we expect it to be, because of all the activity north and south, we expect it to be a North America-wide event. So that's why I built such a very strong chicken coop. It's probably good for a 9.5. It's got parts that are allowed to give, that it's attached to, that articulate in the ground. So that's a good thing. Trailers are great because they're on suspension, and we've shown you the carte blanche, the golf cart modified that will carry all your gear if you're moving on foot, and a lot of people are going to be moving on foot. Now, when is this going to happen? I expect it's going to be within a couple of years, but can I say for certain when it's going to be? Absolutely not. Nobody's ever been able to predict the 9+ earthquakes, the largest ones in the world that accumulate stress for the longest period of time. And this one's been accumulating stress since 1700. The average duration of the Great Cascadia earthquakes is 247 years, according to seafloor core sampling. The best science that is available, and you can count the years since January 1700, when the last earthquake occurred. So it's well overdue compared to the average, and it's getting closer. We can tell by the activity that it's getting closer. So I hope this leaves you informed and gets you forward in preparing. I hope some of you are preparing for the shaking that's occurring in the financial sector as well. God's money is silver, and that's biblical, so we'll stick with that. And that's why a denarius is brought up as part of Revelation. Denarius was a day's wage for a laborer, and for a soldier, I believe, in the Roman army. So 7 denarius to the ounce. That talks about silver being in the range as compared to today of somewhere around $250 an ounce, or $250 for a seventh of an ounce, something like that, 200, 250, depending on whether you're Canadian or US, of course. So I hope this program is informative, blesses you, and we hope that you all stay safe through all that comes. May you have God's blessings over you and your household and family through all of this. Certainly time of turmoil. We see this as the last times, great